The SD Ruby podcast is brought to you by New Relic.
So I'm going to talk about metaprogramming. Originally the talk was going to be a lot more New Relic heavy because I always get questions like, hey, how does New Relic do all this magic? And when I dove into a bunch of the code and I actually ended up starting to talk to some of the engineers that work on it full time, they're like, yeah, this is really more of an anti-pattern chunk of code because we have to support lots of old stuff, and so I don't want to talk about the old ways and bad ways of doing things. So we're going to go through metaprogramming in general, but and we'll see a little bit of New Relic, but we can't do too much. You're welcome to look. New Relic's gem is obviously open because Ruby is open, so if you want to look at it on GitHub, you're welcome to see how we do stuff. But let me just run through some, pleasantries. I'm Chris Kelly. I used to live in San Diego, and I now live in San Francisco. On the internet, I am Amateur Human, so that's things like Twitter, GitHub, SpeakerDeck. I work at New Relic. How many people are familiar with New Relic? Sweet, that's awesome. How many people use New Relic is probably a better question for my boss. A good amount, that's awesome. So, we do instrumentation basically on all kinds of applications. Since most of you know who we are, we won't get into it too much. So, I am a developer, evangelist, coffee drinker, happiness engineer. So I work on stuff like this. I basically write code and screw around with code to talk about it later. So if that kind of thing interests you, I'd love to talk to you about that kind of stuff. There's sort of a booming industry. But really we're here to talk about metaprogramming. So let's figure out what metaprogramming is. How many people would classify themselves as at a level where they do metaprogramming? Whatever that means to you. Okay, so good. Hopefully this talk will give you some description of what is entailed in metaprogramming and what that means and what I think it means. People are going to have differing opinions on this, so mine's not gospel. I hate the idea that it's code that writes code because it sounds too abstract, I guess. Code that writes code doesn't mean anything. It doesn't have any value. What we want to do is write code that makes your application more flexible, easier to extend, right, more maintainable. That's what we want to use metaprogramming for, is to make our lives better. It's not to be clever. If you're trying to be tricky, you're using it wrong because somebody else is going to have to maintain that, or you're going to have to maintain that in 6 months. And I guarantee you I've written code that I've gone back 6 months later and said, I didn't write that piece of crap. And lo and behold, the git blame shows that I did. So I don't recommend using metaprogramming to be clever. I recommend making sure you're focused on one of those principles. Make it flexible or easy to extend, maintainable. So monkey patching is a term that is related to metaprogramming, but I think it's a pejorative term because it ends up being dangerous most of the time. If you're monkey patching something, if you're monkey patching the string class, 9 times out of 10 you're going to do some damage to somebody that's going to use your code later. You might be adding something to the string class, and that's a little less dangerous. But generally, if you're using the term monkey patching to describe what you're doing, you're probably doing something that's not aligned with being more flexible or maintainable. So I think that's really important to kind of think about. And metaprogramming is great for doing things like building DSLs. So Active Record is basically a giant DSL, or it's full of DSLs that help you do things, and it's a big metaprogramming mess. And also drying up code, right? So that's where the maintainability or extendability comes from. It lets us take functionality out of multiple classes and put it into things like modules and mix them in. And that's really what metaprogramming is about. Metaprogramming is really just regular programming. It's things like mix-ins are metaprogramming. We're basically taking functionality and extending it in. So to understand that, you kind of have to understand Ruby's object model. So if you guys aren't familiar with what the term object model means, that's basically this stuff. This is basically what makes up a Ruby object, a Ruby language, all of these components. You probably have seen some of these terms, and hopefully you're familiar with some of them. I know Ruby and metaprogramming can be a very sort of terminology-heavy idea, so getting used to what these things mean and what a singleton class is and and various things like that is really important. So we're going to go over a lot of this and then dive into some actual like examples of how metaprogramming works. And feel free to stop me at any time. Yeah, I'm going to do it. So that's not the highest resolution that you could possibly be, but so we're going to go down a rabbit hole. This is basically what looking at the object model is going to do. So we've got ourselves a wizard class. I'm going to geek out here, so I'm going to mash up some Lord of the Rings with some D&D. So we've got ourselves a wizard class. We've got ourselves a magic module, so things can cast magic spells. We've got characters, which wizards are extended from. So all of these things are kind of what we're going to be referencing over the next few minutes and get a sense of how all these things tie together. Everybody have that kind of grokked in their brain of hit points and magic and whatnot. So we've got a deep gene pool, right? So we're going to create ourselves Gandalf, because Gandalf is awesome. And Gandalf's class is wizard. And that's pretty basic. That, you know, we kind of saw that earlier, right? Class wizard, Gandalf is a wizard, done. Classes have superclasses. So we're going to go up this chain of where these things are coming from. So the superclass of a wizard is a character. And we saw that again on the, I don't have line numbers, but towards the middle. Class wizard extends character, right? So that's the superclass. The superclass of character is an object. As you know, everything in Ruby are objects. And in Ruby 1.9, every object is actually a descendant of basic object. So we keep going up the superclass chain, and we end up with basic object, right? There's a handy method that you can call called ancestors on a class, and that will tell you all of the things that are included in that. And you can see most of the things that we've already discovered, right? Wizard, magic, character, but magic wasn't in that list. So where did that come from? Where does kernel come from? What is that doing? We'll get to that in a bit, but you can kind of see that the ancestor chain gives you an example of everything that's going on.
And they're in order.
And those are in order, and we'll show you a little bit about that. And you can kind of get a sense of that as we go. And yes, everything is an object. Magic class. The class of magic is a module. Module's class is class. Class's class is class. And I think Ruby's kind of trolling us at that point in time. Is what the hell is that like? How do you have a class that's a class of it? Like it's this recursive thing, and it just gone, right?
Turtles all the way down.
So we're kind of at a stopping point, right? Class. The class of class is class. So we kind of have to start looking at the superclass now. So modules, superclass is object, classes, superclass is object, and then we're back up to the object, basic object world. So hopefully you're utterly confused at this point in time, because I made this terrible illustration, which I don't know if this clarifies anything for anybody, but we're going to give it a go. So this is basically a map of those objects in the relationship. So we've got a wizard in the bottom middle, right? And so we've got an instance of wizard, which is Gandalf on that right side. And then there's a module of magic, and character is its class and superclass, and all the way back up to basic object. So you can kind of see how the relationship of wizard gets back to basic object. Now again, still not clear whatsoever, I'm sure, which is fine. So let's take a look at how methods are called, and then we'll find where they go in this ancestor chain. So I just reprinted a chunk of the wizard class for us again, so we get a sense of what's going on. So Gandalf's name is Gandalf, right? We see an adder accessor of name there, so that's kind of close. Gandalf hit points is 3. We don't really know how we're getting hit points out of there. We see a reference to it in the class, but we don't really know how it's kind of getting there. And then Gandalf cast Fireball, there's really no reference to casting, right? So where the hell are these things coming from? So none of those are defined in the wizard class itself, so they must be getting it from somewhere else. So where is cast? Let's start with the instance itself. So the instance itself we didn't define cast on it. The wizard class we know doesn't have it, but it's in the magic module, if you remember. So that's great. Hit points. Hit points are not on Gandalf, they're not on wizard, they're not in the magic module, but they are on character. So basically this is showing you how the method lookup goes. It starts from the instance and works its way up. So first we start with the instance. All right, so we've got Gandalf, we take a look there, we're going to look at its method table. Then we're going to look at the classes methods itself. So basically initializing down, right? So that's a class method, or it's a method, it's an instance method in the class, excuse me. If it's not there, then we're going to move up to our included modules. If it's not there, then we're going to the superclass. And then we're moving on to everything all the way into the basic object, right? Hopefully that makes sense to everybody. So again, as Chris kind of alluded to, it's sort of in order. And if you look at, again, here's our ancestor list, same ancestor list. If we look at all the methods available to Gandalf, there's a giant pile of them. And then we just look at the instance methods on basic object, you're seeing those. And you can see there's a parallel. If we did if we took that array of ancestors and got all of the instance methods off of them, and then compared that with just the methods on Gandalf, you would get an equality. Because Gandalf is just an aggregation of every method that is defined on all of its classes, modules, and the subclasses from them, or the superclasses from that. Any questions thus far? Sweet. All right. So now we've got this thing called a singleton method. A singleton method is a method that's defined on an instance of an individual object, individual class. So if you remember, we started looking at the instance first. So if the instance doesn't have that method defined, then we move on up to the class and so on and so forth. So we could have defined a method on Gandalf himself. In this case, we're going to define a different casting method. So Gandalf the White is just going to be a clone of Gandalf. And then we're going to define a singleton method called cast. It's going to take, the cast method takes variables, or it takes arguments. So we define that in with spell, for example. And then all we're going to do is pass the original call. So we're going to pass that up to super, which is its original method, and pass it the same spell name, and then upcase. That's all we're going to do. So it's pretty basic. So we've got Gandalf cast, he's casting a regular fireball. Gandalf the White casts a fireball, and he yells it at you. He's angry. The Balrog and everything. So that's what singleton methods are doing. And then there's a thing called Singleton Classes. Hopefully I haven't just entirely lost you with too much information. So we've got Singleton Classes, we've got Gollum, we're just going to create an object. So the thing about Singleton Classes is, Singleton Classes are also known as Metaclasses. They are invisible classes that exist between the object itself and its actual class that things can attach to. So we've got Gollum, which is an object. We define a method on Gollum called speak, so that's basically doing the same thing that we did previous. So Gollum's class is an object, we're good with that, right? But if we can extract out the metaclass, which you see in that middle ground, right? Where we're basically just returning the class itself into metaclass, and we look at metaclass, this class, it's class. So you can see there's an extra class in there that we couldn't really find, you can't really get to in other ways. We can kind of be tricky and get it there. And if we look to see what instance methods are defined on that metaclass, you can see that's where speak ended up. The speak is not on anything. Speak's not on object, it's not on anywhere. It's hiding on this metaclass. Or I believe there's a German for like Eigenclass, I think is one of the other phrases, which is weird. Germans. The reason I'm passing false to instance methods is I don't want to inherit, I only want to show methods that are defined on that specific class itself, not all the things it's inheriting. So object and basic object will pass over lots of other things like equality methods and whatnot. So false stops you from doing that.
Hey Chris, Eigen is German for single.
Sure, if you say so. I'm going to treasure all on that. I cannot verify. All right, so all of that, the reason the object model is extremely important is because basically metaprogramming is just simply getting methods to where you need them. It's creating random methods and or functionality and sticking it into the various objects where you need them. So sometimes you're going to be putting it on superclasses, sometimes you just want it on a singleton object, any number of things. But that's what metaprogramming is, in my view. Other people have different views, I'm sure. So here's some tools of the metaprogrammer. The very first tool of the metaprogrammer for Ruby, the reason Ruby is such a great metaprogramming language is it has open classes and you can just basically rewrite all the methods. You can stomp on the stuff that was written before it and change it, right? So In some cases, we have a module canine, and it's got a method called bark, and that makes the object go arf. Now I've got that on tape. So we create a dog class, and we include canine. So basically, as we're going down, as Ruby's executing this code, the class dog gets defined, then the include canine, so we're basically injecting the def bark arf, the arf version of bark there. Then we just immediately rewrite bark to be wolf. And then finally we reopen class again, the dog class again, and rewrite it for a third time to be yip. So the very first thing that a metaprogrammer needs to understand is how open Ruby is and how vulnerable that makes you. Because if you use libraries, and we all do, right? We all use gems. Those are just libraries that have people doing crazy things in them. People can do crazy stuff in libraries, and just opening up random classes can do damage. So when you're a library writer, please be polite and don't step on people. Namespace your things. That's a good policy, so that you're not stepping on somebody's regular class, especially using like regular verbs, like person or user. Chances are the code that your library is going into probably has a person class or a user class, so you don't want to be stepping all over that. So you might want a namespace. So the next tool of the metaprogrammer is define method. So that's basically giving us a way to dynamically create methods on objects, or on classes. So basically these two things do exactly the same thing. The one you're going to use as a metaprogrammer is the define method on top, for the most part. It's cleaner, it's easier. I'm using staggy lambdas because they're just kind of slick looking. But they do exactly the same thing. So remember to use define method. So basically what this is creating, you're passing the variables that you as arguments into the staggy lambda, and then it ends up getting passed into the new method. So you can see how those correlate. That's how you would write a bark method that takes a string of how to bark.
For the benefit of those people who don't know what a staggy lambda is, can you point out on your slide what staggy
lambda is? So staggy lambda is right underneath that top arrow. It's the arrow and then parentheses sound. That is, the staggy part is obviously the arrow. The lambda is in the curly braces that come after the parentheses sound. By putting something in the parentheses, I'm assigning a variable to push past into that lambda. And then I have access to it inside of those curly braces. Thank you. So define method. It's pretty straightforward. You're not gonna, this is going to be a massive tool for you. Class eval. That's basically taking a class and executing some code into it. So in this case, we're going to do basically the same thing we just did. We're opening the class, evaluating a new defined method onto it, and doing exactly the same thing. Nothing special. In this case, all we've done is change what bark does. We've given it a loud bark this time. So those two things are what you're going to use quite a lot. There are other components to metaprogramming, but I think those are two good ones to start with. And then the next key to metaprogramming is callbacks. So Ruby has this ability to monitor what's going on in your objects and in your classes, and then make all sorts of weird callbacks. And you've experienced some of them already, you just don't know it probably. The first one is inherited. Inherited is basically when a class is extended to a subclass, then you end up giving a callback to inherited. So you can put whatever code you want inside of inherited and act on that. This isn't a common used one, but it's sort of the most basic of what goes on. So really, if you wanted to have some kind of random callback for, I don't want to make an example with it. Included is a very common one. So this is executing code that happens when a module is included inside of another class. So we define the module magic, we include it into wizard, execute some code, and that happens. And including a module is basically taking a module's instance methods and putting them into your class. And you might want to do various things. And so this is very common to do generating dynamic, say, adder accessors. And we'll kind of look at an example for that in a bit. So, and then there's extend. Extend is similar to include. It's doing the same thing, just when you extend a module. Extending a module is taking your class methods in the module and extending them onto the class itself, or taking the methods in the module and extending them to class methods in the class. So the difference between class and instance is relevant there. Another callback is method added, method removed. Those are pretty basic, so those are kind of interesting. Again, these are all just very kind of straightforward, so you can see what we do is we just add a method and we fire off the callback for adding a method and then removing one, so on and so forth. So I don't use this one all that often. I'm sure there's use cases for it, but I haven't messed with it. And method missing is the one you're probably most familiar with. It's also the most dangerous. It's probably the one you start with. It's sort of a catch-all, right? So method missing is a callback that gets called when a method does not find any resolution on an object. So all the way up to the ancestor chain. So there is one method missing defined on basic object, and all that's going to do is take the method name that you called it and output an error to standard error that says no method error and output the method name. That's what the original method missing is doing. So you could find that when you're extending a class, when you're creating a method missing on another class, you're overriding that one. And so what you always want to do when you're using method missing, in this case, what we're doing is creating a dynamic method call, so we can cast any kind of magic spell we want. So I can say Gandalf.cast fireball, and it will, regardless if I have a cast method or a fireball method or anything like that. So what we do first is we take the name of the object or name of the method that's missing, because there is no there's no cast fireball method, or in this case cast banish Balrog. There is no method there. So what we do is first we do a regex to see if it matches the case we want. In this case it does. So then we basically strip off the names or the cast so we can get the name out of it, and then just call cast on it. Ucast banish Balrog. If it doesn't match the cast underscore, then we want to pass that on, right? Because if we didn't have this else super, what we would be doing is we'd be interrupting Ruby's basic object's method missing. We'd stop it from functioning because we're overriding that method now. So what we're doing if it's not matching any of our cases, we then pass on to super, which then finds its call chain all the way up at basic object and then just continues on outputting the standard no method error that you're used to seeing. Well, hopefully you're not used to seeing it. So yeah, and then all of the arguments that are in that scope, so the name, the args, the block is potentially being passed, will automatically be passed up to super as well. So that's method missing. And any questions thus far on tools of the metaprogrammer?
The method missing is used extensively by active record for those
Yes,
dynamic finders.
that is exactly what method missing. That's exactly what active record is. So if you're calling person.name and the name is just being magically created with method missing, you can dig into that. That's a good example of one. We're going to go through a basic example of creating dynamic getters and setters. So normally if you want to access instance variables, you would define the name, return the instance variable name, set the instance variable name with name equals, right? So that is if Ruby did not have adder accessor by default in standard lib, this is what would happen. This is what you would need to do that. We want to create them dynamically. So we're going to create a module called getter and setters, and we're going to define a method on that module called getter and setter. And we're going to take each of the attributes that's being passed to this getter and setter method, so on the second to last line. So we're going to take each of those attributes and we're going to define a method for that. We're going to, in fact, define two methods. One for the return value and one for the setting value. And so that's pretty straightforward, right? So define method attribute, which so in the first one is name, instance variable get, and then we just interpolate name to be the instance variable for it, and we generate our getters and setters. And so that gives us the ability to create a wizard that the wizard class, as you saw, doesn't have anything in it, doesn't have names, and doesn't have magic points, doesn't have anything related to it. But we can set names, we can return them, we can set magic points, we can return them. Pretty big. That's pretty straightforward. And I think that's the kind of metaprogramming as a good quality citizen to the library world you kind of want to practice. That's relatively straightforward to read. It's extremely powerful on what it's capable of doing. It should probably have some documentation to some extent, but that one doesn't. So let's look at a New Relic example. I did find what I think is a good example that kind of exemplifies some of this, and I'm running a little over, but you won't mind that because I'm buying gear later. So you'll wait for me. So a New Relic example, we're going to take a look at Unicorn, the web server. Unicorn actually, if you're interested, has some of the best Ruby programming and systems programming I've ever seen. It's amazing. So if you're interested in some of this stuff, it's really rad. So what we want to do is time that. So what New Relic's basic functionality is we take a method, we clone it, we create a new method with some timing wrappers, and then execute that original method's name. And that's what we're doing here with Unicorn. So the things that you're going to start to notice is in that executes block. So in the executes block, the first thing you notice is we've got unicorn HTTP server.class about. So we're taking the original unicorn HTTP server class, and we're now stepping on it. We're going to take it over and do something with it. The first thing we do is create an old worker loop. So this is the original worker loop, which is a method name. It is a method in Unicorn, and that's basically the worker loop. All it does is sits there and waits for connections, processes them, and then sends them on. So it's the thing that's actually processing a request for you. So first we want to generate an instance method for that, and we store that in the old worker loop variable. And then we want to define a new method called worker loop. So we're basically going to be replacing the original worker loop, which has a lot of code in it, with our very small worker loop code. Worker loop takes a worker parameter, so we have to pass that on. And then we're going to initiate the New Relic agent and the after fork isn't really that relevant. And then what we're going to do is call the old worker loop, bind it to self, and we'll talk about it in a second, and then call that method, the old worker loop method, with the parameter worker. So we want to re-execute the original worker loop method. So that's probably 5 of the things that we looked at earlier. The thing that's most important about this, and the thing that's really the most important about metaprogramming in general, is understanding self. Understanding what context you're in and what you're taking action on is extremely important, and that's where you're going to spend most of your time debugging, is to figure out what self is at the time things are being executed. So in this case, we start with unicorn HTTP server class about. So now self is defined as is the unicorn HTTP server. So when we move to the next line below that, instance method worker lookup. So instance method has an implicit receiver of self right now. So self, you can rewrite that as self.instance method, and then we're basically looking at the original worker loop. So now currently self is still HTTP server, right? We move through a couple lines of code, so we redefine the new method, and then we bind the old worker loop to self, so it gets executed there, and then it gets called. So we move through a couple layers of self and move ourselves back out, and that's really important to know what we're working on. Hopefully that makes sense. I didn't get a chance to add some slides on self itself, but know that learning about self and how to identify what it is really important when you're doing metaprogramming. And that's it. Thank you. Drinks are on us. I do warn you, I may try to recruit you. There's New Relic is hiring. I know people don't like San Diegans moving away from San Francisco. They think it's a drain, but I am a transplant, and I can sing the praises of that. But I gladly take questions if I can answer them. If not, I'm sure there are much smarter people in the audience that can. So, questions?
Metaprogramming questions? There have to be oodles of them.
You used a stabby lambda in one defined method and then a block later.
Mm-hmm.
Is there a difference?
There's not technically a difference. I probably was using it in the different contexts for space reasons more than anything. So, and there are paradigms for when you use the single line stabby lambda versus a block lambda. There isn't a difference between the two. They do the same thing.
So, I got a question on callbacks.
Yeah.
Okay. So, are all callbacks like added to a callback stack, or like can you accidentally override a callback by adding? So say the callback is like included, right? So when you're adding something to self.included, do you overwrite whatever was existing in self-included, or do you add it to an include stack? And more importantly, if there's already a bunch of callbacks, can you cancel a bunch of them, and how?
So I think I understand your question. I'm not positive. As far as I understand is you cannot interrupt a callback. The callback is being made in a meta class, which you don't really have access to. And so in the same way that you can't override initialize, because that's really just that's a callback off of the new method. And you can't get in between those two things because they're being called in MRI in the C code. So I don't think you can, and I've never seen an instance where you can either override them or interrupt them. So if somebody has experience or knows that, I would gladly take their correct.
Redefine them because they're reserved words.
Yeah.
So included is a reserved word in Ruby, and it's just going to throw up at you if you try to do def included.
I guess what I was like asking really is like, if you've got like self-included in one class, say in character, and then you write self-included in, I guess, well, it would happen in modules, but, and then you have it in wizard, like is the wizard one overwriting the character one, or is the...
No, because that has a reference back to self, right? So included is referencing the wizard class, and you potentially could reopen the character class and define included again, and that would step on it. But you couldn't do it from inheritance purposes.
Included only gets called when you include a module. It doesn't have to do with inheritance at all. So if you're subclassing wizard, you're not calling the include.
That's its own include callback.
Right.
That will only get executed when you use include on that module.
Yeah.
Anybody else? We're going to show you how to set up.
If you don't mind, could you go back to your slide about that showed you how you got to the meta class, or
Yes.
it lives, and I believe that lives, every class has that.
Yeah.
And can you just explain that line of code?
Sure. So I think you're talking about the metaclass equals class, definitely that one. So what's happening is I'm opening class, right? So how do I explain it right? So I deleted that slide that has kind of the various ways to define things. So all we're doing is opening the class. We're trying to add something to the class of Golem, and all we're doing in that is returning self. So at that point, this is where self is really important. So the second we open class for Golem, we're now injecting something onto Golem's class. And that we have self, and then we theoretically could do any number of things. Self-defined method, instance about, any number of other things. All we want to do though is return self, because that's what it is at that point in time. We're now we've opened up Golem, and we're now in the self context inside of Golem. This is weird. And all we want to do is return it, because that's how I can. There's very little value to learning. This is not a technique for anything. This is simply demonstrating that there is what's known as a meta class existing that you can attach things to. So we open up Golem's class. That puts us in the self context. Self is now the context of Golem's class, and we just return it back out to store it in the meta class variable. Does that kind of answer your question? So on any number, like in Golem's speak, the second definition, or I guess first definition, right? Golem.speak. We could have written that differently. We could have written class, double angle, Golem, define, speak, and then done it that way. So what we're doing is we've opened up, we basically have said, here's Golem's class, and then define this method on top of it. But we're, in this example, I'm going to move out, Patrick can go upside of me. In this example, we didn't do anything. We didn't actually define anything. We just simply returned self. So, like, I don't know if I can live code something that will make any sense.
While he looks that up, I will put a plug in for the Metaprogramming with Ruby book that's out there. It's a really good reference, and Chris has done a great job of bringing a lot of the topics in that book to life here on the slides. But if you want to get some hands-on practice with the Metaprogramming Ruby book is fantastic, actually.
You guys will go over it. So these are fundamentally doing the same idea, right? So they get us into the context of Golem, and then I probably can't see that, huh? So we get into the context of Golem, and then all we're doing is returning self, because all Ruby code does is just execute line by line as it's reading in the file. So we execute the first line, get into the context of Golem, and then we just return self, because that's what that line of code does. And so we just have now taken out, self at that point in time is the meta class of Golem. In the same way that if we go here, this is the same thing as that. Self is implied on speak, right? Self is implied on all method calls. So we're attaching the same thing, but we don't really care about defining anything. If you remember that versus
You have an object, Golem object at that point, right?
yeah, I have just a basic Golem object, but the object isn't a class. It's just it's a pure Ruby object. It doesn't have a class. If we did class on it, it would return nil or return object. Right? So you can see the similarities in this section here to what we just showed, right? Where the self.speak is defining on Golem. So that's kind of how we got into that context and returned it. I don't know if that helps at all, but
Yeah, it does. I've never seen that way to actually, not that you'd use that in code, but a way
The
to
class
actually.
double arrow Golem is how you reopen a singleton,
yes.
because it doesn't have a traditional class context. So he's reopening the singleton there.
And you can't define instance method on Golem, like in the same way that we did it on another slide, define singleton, because it's a singleton class, and so Ruby's going to say, no, you can't do anything, this is a singleton, leave it alone. It throws you an exception. So you have to do it that way to trick it.
It is the single most confusing thing I think in metaprogramming is that particular construct right there.
Yeah.
You see that in a lot of places.
Yeah.
Anybody else?
It's unfortunate they just don't expose that, it's sort of a hacky way, if you return self out of it. I think there's some libraries that actually define eigenclass and call it on a class.
The point of a singleton is that it's immutable.
Well, but I know people are doing that all over the place, so it's.
So people would define a method called eigenclass that calls that, so you could access it?
Exactly, you could define, you could define that.
I don't know if that's a thing you should do. That's starting to either get clever and or be uppity about metaprogramming. This is simply an illustration, not a recommendation. None of the code in here was a recommendation for how to do things. It's an illustration because metaprogramming requires some trickery. So I wouldn't recommend getting to the meta class and doing anything with it.
Well, you might want to create another object that's got the same methods as Golem.
Yeah, but you can Golem clone
So
that.
you could create a
Or do it.
subclass of this meta class by getting at it this way.
You can't subclass, so I tried that when I was screwing around. I can't create a new object out of Metaclass. It's a singleton class and it won't let you. I tried that. Because I'm like, can I create another, now that I defined speak on it already, can I create a new object with that class? And it throws an exception. Which I thought it was going to be really clever. I'm like, oh, look at me. Nope, didn't work. Because if you check Metaclass class, it's a class, so I should be able to define something off of it, but I can't. So.
Another place you might see the class less than will have self on the other side of it. So it'll say class less than self. It's another way of defining class methods.
Yeah.
You'll see that in gems all the time.
Yeah.
And plugins or.
And that's a stylistic thing. Some people use self,
Right.
some self dot, and then the method name. Some people use class returning self, and then define it within that block. I prefer the self dot method name.
You can also use the class name dot
Yes.
to get the same effect.
Ruby and your 15,000 ways to do stuff. Love it. So that's partly why understanding the object model, where self is, and will help you understand when you're reading other people's code, what the hell's going on. Because you can do it, the three of us would probably do it differently. Anyway, I would love to chat with you guys more about this or anything, and I will gladly buy you a beer so don't skip on that. And I think we have a raffle and stuff coming up. So thank you very much. Appreciate it.